Most planning systems are based on what's known as batch logic. It has a major flaw, and I want to describe that flaw using a buffer tank. Now, this buffer tank I've drawn using batch logic. Let's give it a name. Let's call it the warehouse, because that's what warehouses are. They're designed to balance supply and demand. There's an outlet valve called customer demand. This valve is permanently open, it's just the demand goes up and down. There's an inlet valve called production, and every single time you run the plan, the logic goes like this. What is my expected demand? Will it take me above my target stock level or below? If it's above, then the production valve stays shut. If it's below, the production valve opens to bring the stock back to the target level. As a result, every single time you run the plan, you will get a different plan. Guaranteed, 100% guaranteed. Why? Well, there are three key pieces of data needed to calculate the plan. The first one is the sales forecast. Does it ever happen in your company that you sell different to forecast, only like all the time? Secondly, production. Production gets the plan. Does it ever happen that production made a bit more or a bit less than what the plan says? And lastly, inventory. Could it possibly happen that what the computer says is in the warehouse, what's actually in the warehouse, is different? These three key pieces of data change all the time. Therefore, every time you run the plan, you will get a different plan, which results in short-term plan changes. Short-term plan changes, in other words, changing the plan after it's been issued, are endemic in all the companies I work with. It just amazes me, companies, well-known companies, big well-known companies, the number of times they change the plan after it's been issued is truly shocking. Hardly a situation for an efficiently run factory and supply chain. Does your business ever make short-term plan changes, resulting in firefighting? I assume everybody understands the term firefighting because it happens everywhere. So what's the alternative? Well, the alternative logic is called flow. And what you're trying to do is to replicate how a real buffer tank actually works. With a real buffer tank, there's an outlet valve that's permanently open. It's just the demand goes up and down. There's an inlet valve, which also is permanently open, and the liquid continually flows through the tank, hence the term flow logic. There's an upper and lower level, and the level in the tank is allowed to fluctuate between these. If it ever touches the upper or lower level, they're automatically connected to the inlet valve and will adjust the inlet valve, not close it, adjust it to bring the levels back into control. It's a fully automatic system. Nobody needs to touch it once it goes into place. Right? And this is what we're trying to replicate in the warehouse. So batch, unstable. Batch logic is an unstable process. What we want to move to is flow, which is a stable process.